Hello everyone. What we're looking at today for primary science is viscosity. Viscosity is how runny a liquid is or how thick it is. So imagine trying to run through a bath or a swimming pool full of honey. You wouldn't get very far. So all liquids have slightly different viscosities. Some are very thick and very viscous. Some are very runny and not very viscous. So the water in this kettle is quite a runny liquid, so we'll say it's not very viscous. The cooking oil in here is a bit thicker than water, so probably a bit more viscous. And again, the washing up liquid in here, it feels more viscous than water, so it's probably more viscous or thicker than water, but how much more? So what we're going to do is an experiment, and you need 3 bottles. Okay, I'll show you how to cut the bottle, how to doctor the bottles. The bottles need to be identical. So I have these 3 water bottles, which just lying around, which I could use. You need some way of holding the bottle up. You can do it by hand, or if you've got some kind of clamp, you can clamp it up. And you need something to catch the liquid at the bottom, and you need something to take a time. You also need something that's going to be able to make a hole in a bottle. And I use a little palm drill, which is fantastic for this. You can use scissors, but obviously be careful because they're pointy. So with the palm drill, firstly you need to make a hole in the top. So I'm just going to work it through as close to centre as possible. And there we go, a hole in the lid. Absolutely fantastic. Now you need to make a hole. Well, let's just tidy that up a bit. That's where the scissors come in handy. So hole about that big, absolutely fantastic. And you need to make a hole somewhere else in the bottle. Now this bottle's got little rings on it, and I'm going to make a hole just above the second ring line, so just there. So it's easier if you leave the lid in, so I'm just going to stab a little hole with the scissors and carefully work it round. So there's a little hole in the side. I don't know if you can see that there, just there, little teeny hole, and that hole in the side I'm going to cover up with some tape. Hole inside, a puncture repair kit, piece of tape, and I'm going to leave a little bit of the tape just sticking out so I can pull it off nice. So now I've got 3 bottles, each one's got a hole in it at the same place, each one's got a hole in the lid. One's going to have washing up liquid in it, one's going to have cold water. You can use hot water if you want, I don't really care, but I'm going to use cold water. And one's going to have cooking oil in it. Now you need the same amount of stuff in each one. So I'm going to fill these bottles up to the second line, which is just below, and that's really important, just below that hole. So I'm going to put that much water or cooking oil or washing up liquid in each one. So it'll be quite a bit, but you can get it back afterwards so you're not wasting it. So this is to the second line of my bottle. Okay, let's try washed up liquid. Washing up liquid's easier because I can just do that. There we are, same amount. So that's the first line. Okay, so the next bit is to hold up these bottles. So what I'm going to do is I'm going to invert the bottle, turn it upside down, and this ring thing I've got here is just about the right size. And I'm going to start with the water, which is that one. And I'm going to tip it upside down. Now, to measure the time it takes, you can film it. So you can use your phone to film it, or you can use a stopwatch if you want to. And the reason that we've got this little tag on the side, this bit, is that when we're ready to go, rip it off, and that allows the air to go in, which allows the water to go out. So the first one up goes in there. Make sure it's above whatever container you're running it into. Off comes the sticky tag, and How long does it take to empty? Just finished there. Okay, 3, 2, 1, go. So hard to tell from here whether it's faster or slower. It's certainly rolling out. So if that liquid is thicker and more viscous than water, it should take more time. If it's runnier than water, it should take less time to run out. It doesn't make any noise. Water makes a noise. Cooking oil doesn't make a noise when it's running out. So just finished there, I think. Right, cooking oil is back in the cooking oil container. So last and definitely not least, we're going to try the washing up liquid. So same as before, put it over, put my finger over the end, pull the tag off, so the air holes ready to go. 3, 2, 1, go. So again, if this liquid's thicker, it will take longer to flow. If it's runnier, it will take less time. Viscosity is the word. Viscous means runny or thick. It's how thick or runny a liquid is. So it's hard to tell. It's coming down near the end. Lots of air bubbles in there. Just about finished. Let's see. Oh, we've got, yeah, still got quite a bit. How to judge when it's stopped flowing. That's definitely still flowing. A little bit coming out now. Yeah, I think we can say that's finished.